Welcome back to Acing AP Bio. Today we're discussing chemical bonding. An ionic bond is a bond between a metal and a nonmetal. Recall that electrons are negatively charged. The metal gives up an electron to become a cation, or an atom with a positive charge. The nonmetal gains an electron to become an anion, an atom with a negative charge. Remember that atoms want to become stable by fulfilling the octet rule. So sodium, a metal, will give up its electron, and chlorine, a nonmetal, will gain an electron. The attraction between a cation and an anion forms the ionic bond. Ionic compounds are called salts, and they dissociate into ions in water. A covalent bond forms between two nonmetals. The bond forms due to a shared pair of valence electrons. There can be single, double, or triple covalent bonds. Triple bonds are the strongest. Now let's talk about the difference between a nonpolar covalent bond and a polar covalent bond. In a nonpolar covalent bond, electrons are shared equally among the atoms in the compound. This is due to all the atoms being equal in electronegativity. Electronegativity is the ability of the atom to attract electrons. Fluorine, oxygen, and nitrogen, or Fon, have the highest electronegativities of all the elements. In H2, both atoms pull on the electrons equally, and so the electron clouds surrounding the nucleus are the same for both atoms. In a polar covalent bond, electrons are shared unequally due to a difference in electronegativity among atoms. For example, in water, oxygen pulls more strongly on the electrons, and so it has a much larger electron cloud than the two hydrogen atoms, making the compound polar. Those were intramolecular forces. Intra means within, so the bonds within the molecule. Now, let's talk about some intermolecular forces, or the bonds between molecules. Hydrogen bonds are essential to biology. Hydrogen bonds form between the slightly positive hydrogen atom of one polar molecule and a slightly negative fluorine, oxygen, or nitrogen of another polar molecule. For example, H2O. The slightly positive hydrogen atom of one water molecule forms a hydrogen bond with a slightly negative oxygen atom of another water molecule. Hydrogen bonds are the strongest intermolecular force. They are weak individually, but strong together. Next, we have dipole-dipole interactions, which is the attraction between two polar molecules, for example, like HCl. The slightly negative chlorine atom of one HCl molecule forms a dipole-dipole force with a slightly positive hydrogen atom of another HCl molecule. And lastly, we have London forces, also known as van der Waals forces. London forces are the attraction between two molecules that is due to a shift in electron cloud symmetry. Attraction between two nonpolar molecules can only be a London force. It is the weakest intermolecular force. Let's look at the bond formed between two H2 molecules. At first, the electron clouds are the same size. However, when there is a shift in electron density, one cloud becomes larger than the other. The attraction between the slightly positive and slightly negative ends create the London force. In the next lesson, we will talk about how hydrogen bonding gives water its properties, and its properties make life on Earth possible. See you then! For more bio content, hit subscribe.